So good afternoon, everyone. So please, can we hear me?
It's a bit low.
So what about now?
Yeah, much more better now.
Okay, thank you. So I think in our last class we stopped here. Yeah, so like I said, this class is going to be very short. So, and it's just going to be the continuation of the last class. So our last class was on, unit data compression. So we started with a lot of things. So I started by telling you why data compression matters. I'll also talk about, the popular compression tools that we use, in informatics. And I told you that Zip, bzip2, and gzip are the most popular. And I also told you why gzip is, gzip tool is the most popular in bioinformatics. So, and if you actually look at this table, so you can see why it is very popular, because the relative compression is medium, and also the speed is very, very fast compared to the other tools. And I also told you about the other compression tools that we are not going to introduce to you in this particular topic, but we will come across them in future class. And one popular tool that and these popular tools are the SAM tools and the VCF tool. For SAM tools, you will use that one to compress alignment file, files that you've aligned. Reads that you've aligned. So it's just a file that actually contains information about your your mapping and alignment. And then because this particular file, so it tends to be very, very big, and it might be very difficult for probably these compression tools that we talked about to actually probably find an efficient way to compress them. So the developer of some tools has actually probably done a good job in giving us, a way to actually compress some files. So like I said, some files contain, files, your alignment files, files that that contains information about your mapping and alignment reads. And also, I told you a little bit about bits and bytes. So I told you that, all the characters in our computers, whether your A character, your alphabet character, your numeric character, things like that. So, everything are decoded using bit and bytes. And we have like just 2 bits, 0 and 1. And then, the architecture, so whether you are using, depends on the kind of computer you're using, whether you are using 8-byte architectures or 32 bytes or 7-bit architectures. So most computer actually uses, most computer use, I think, 8 bytes, and also we have the Unicode. So we talked about all of these things and why, like, everything started from 7-bit architecture, then we went to 8-bit architecture, and then the most popular computer now uses Unicode, because with these Unicode architectures, it turns out that you can actually store, assign the unique byte to every characters that you have on your computer. So, and then we started looking at, the zip file, the first compression tools, which is the zip file. So we show you the syntax. We have this, we have that. And I told you that zip2 actually does 2 things. Number one, it compresses individual files and or folder first before bundling them. Just important. It does this thing to process. It says probably you are trying to, like, you have more than one files or folder that you are trying to, like, combine, compress. What is going to happen is going to first compress all of those files or folders individually before bundling them together. So it does 2 things. It does compression, it also does bundling. And I also told you that this might not option of like is necessary when you are trying to like work on folders. That's probably the files that you are trying to like compress. I mean, within the folder. So I mean, just use minus R when you are doing that. And how to decompress, I mean, it's actually very simple. What you have to do is press this command on zip and then the path. So where you have your zip file. So we also saw tar. So I told you that tar is a way similar to zip, but tar in a way is not really a compression tool. It's just like tar itself is just like a way to actually bundle to bundle things together. So, but there's an option that you can add that might actually turn tar to a compression tool, and that option. So you have the minus Z, you have the minus V, you have the minus G. They want to probably, like I told you, tar bundles by default, it doesn't do compression. But there is a way you can actually modify the default behavior of tar and then turn it into a compression tool or the compression tool. And the options that you can use to change the default behavior of tar are the minus Z or minus V or minus G. So if you are using this, probably you are interested in using the gzip compression. So just use the minus Z option. And if you are interested in probably using the XZ, use the minus G compression. And if it is bzip compression, so that you also use the minus G. And I also told you that order actually matters when you are doing it. So, but what you have to have at the back of your mind is that whenever you are trying to like work with tar options, so F has to be the last option that comes last. Otherwise, so the compression will not work very well. So whatever you are doing, make sure that minus F is always the last compression that the last option that comes in the list of compression that you have. So otherwise, your tar compression is not going to work. Then, so just like you can compress with tar when you actually probably use the minus X or minus J or minus capital and J option. So you can also decompress, I mean, a tar compressed file. And the way you can actually do that is to introduce this minus X. This minus X means extract, and extract also means, I mean, decompress and unbundle. So it's going to like how you do this thing. So there are two things that will be done. It's first going to like decompress and then unbundle, and then you have your original file. So this particular syntax, this command you are seeing is doing two things. It is, so the first thing it's going to do is it's going to first decompress, and then after that, it's unbundle. So that is actually the order. And then, so we because we ran out of time, so we're unable to actually talk about the last compression tools. So, and I said in our last class that I will be talking about it today. And then, so we just have like 2 slides, and then we are going to end this class. So the last 3 compressions tool we are going to talk about is the gzip, the bzip tool, and the XZ compression tools. So from the brief introduction about this particular tools, so what do? So they don't bundle files and or folders. They don't do any bundle. So what they just do is they only compress files. So you can actually probably just see them as a core compression tools. They were written only for compression, not for bundling. So they don't bundle files or folders together. So if you want to probably bundle, you should be using probably zip tar. But let's probably are just interested only on compression. So just use this this compression tools rather. So use them. They don't bundle, they only compress files. And this is a general syntax. You can see I just bundle all of them together because their syntax is very similar, very, very similar. So the only thing that is changing is just the name. So like I said, so probably if you're interested in using the gzip compression tools, just use gzip and then keep all of that things constant. And if you're interested in bzip2, so use bzip2 and then keep all other things constant. And if you're interested in exec, use exec and keep all other things constant. So aside from the name of, the name of the tools that is changing, the other things, whatever you can do with one, you can also do it with the others. So that's actually the takeaway from the slide. That's okay. So that's why I have bzip or bzip2 or exec, and then all of these things. So we have there. So and one thing about this thing is, so if you actually want to pass the files to actually compress, you can pass one file or multiple files at the same time. So that's why I just put this one as list of files. Let's say it's just one particular file that you're interested in compressing at once. So it's going to work. But let's say probably you want to pass as many files as possible at once. You want to compress them. Like by pass, so this is the pass I'm talking about. So I know the spelling, not this pass. So I think probably we should just show some example. So I cd, if I cd into let me see analysis, let's cd into full. So this was the directory that we created in our last class, just to demonstrate the utility of these tools. So we created a lot of files that I will be showing you. So you can see these are the files that we have in this directory presently. We also have a folder within it. We have a script. So a script file, bash file is also like a text file, but just to distinguish, but this is a bash script. So we have some other files that we've created, and we've compressed using zip, we've compressed using tar with the -z option. So these are the things that we. So let's probably now want to probably use gzip. So with gzip, you can just say, so as I always do. So these are so if you want to know the size of your files, just come here. So look at all of these things. All of these things that you are seeing, 177, 177, 335. So they are the size of your files that you have. So this one say, okay, this particular file is 177 bytes. So that means you have like 177 characters within this particular file. Because as we said in our last class, that 1 byte is equals to 8 bits, and it's also equals to 1 character. So if I'm saying bytes, it should be okay, I have character. So if I say I have 177 bytes, it means I have 177 characters within this file. And if you want to convert this to probably bytes, just multiply it by probably 8. So I have so this one also we have 335. We have 235 bytes. So that means we have like 235 characters. So this one is saying you have 9.5 kilobytes. So that means you have 9.5. So you just have to probably multiply this one by 1,000. So that's going to give the number of characters that you have. So and so on and so forth. So what we did is we want to see this too. Let's start with gzip. So this is a gzip. Let's gzip command. So this is how we type it, gzip. But let's say we want to compress this particular file. Look at this. So if you put it here, so I didn't put option and this. So the common option that you can use is this. So if you are using -k, so that means you want to compress and then delete the original file, which actually makes sense because whatever you compress with it to, by the time you decompress it, you also get the original file. So let's probably you don't want to delete it. So if you don't want to delete the original file, you can just use -k. But by default, whenever you are compressing with any of these tools, they will compress that file, the original file that you pass into the command, and they will delete them. So if you now want to probably get back the original file, all you just have to do is decompress them, and then you get the original file. I'm not sure whether you understand what I'm trying to talk about. I said, whenever you are compressing a file, using any of these tools, they will do the compression for you and then delete the original file, I mean the starting files that you pass to this command. So let's see what will happen if I do this thing. Before I press enter to run the command, we can just probably anticipate. Let me ask you, what do you think will happen after running this command? What do you think will happen to sequence.txt? Will I get that sequence.txt back after running this command? Will the compression work? So I'm throwing the question open. Can somebody just anticipate what's the result of this command will give us? Anyone anticipates? Anybody can talk. Or Tuchuku can find somebody for me.
Anyone can go ahead, please. Or Trisha, can you help us out? Okay. Austin said the original will be lost.
The original will be lost. And what else do we anticipate?
Then sequence.txt will be compressed.
Will be compressed, exactly. So let's see whether our work. So then ls minus lh, we can see we no longer have sequence.txt. What we now have is what? Sequence.gz, right? Sequence.gz. But look at the size of the file. Initially, the original file was 7 bytes. Now we have 40 bytes. Can somebody tell me why we have this observation? So why do you think? Do you think this compression, to you, do you think it work? You are trying to decompress, reduce the file, the size of the file. And then after doing that, see the size of your final even, rose high. So can somebody tell me why that is the case? So this was something I actually said in our last class, or I just want to know probably you guys have been following. Can anybody tell me why we have this observation? Normally, I would expect the size to be less than 7 after the compression, but now we have 40 bytes. So do you think this compression work efficiently? Anybody?
Sorry. Okay, so Joseph posted that possibly the name change and other properties were added.
Exactly. So, in the last class, I was telling you about something about limits, but I'm not sure whether you guys actually took a little bit of further maths in secondary school or in undergraduate. So in calculus, so there is always something we call limits. So that's why we have like a limit of a function now. So it's just, the limit where that particular function actually holds true. So it turns out that for all these computation tools that we are seeing, so there is a minimum number of characters that a file must have before the compression can actually work very well. Otherwise, we are compressing a small file, you will always, the compression will not always work. So you need a minimum of at least the file. I don't know what the maximum is, but you need the minimum number, minimum number of characters before the compression can actually work efficiently. So that's actually what I'm trying to talk about. So you actually see that if I should look at this particular one, 3.2, I will just try and compress this, and you will see that GC will actually do a very good job in compressing this particular file. You will see, and that is because we have a lot of characters in it already. Just to show you what file txt. So if I do this, gzip file1 .cst, I'm trying to compress this. Look at it from 1.0k from 4 kilobytes. So by the time I run this, I expect the file size to have reduced. You can see we now have 60. You can see from 40 kilobyte, I mean from 4 kilobytes rather, we now like 60 bytes. And that is because, I mean, probably this one is actually within the limits of the characters that these compression tools are expecting before they can work optimally. So that's just take away from this thing that it's not all the files that you compress. I mean, files that are already small, they don't need to be compressed. If you try to compress them, in fact, some extra characters will even be added to those files, like probably the size of the original file, the name of the file, things like that. So they will always be, I mean, appended to your compressed file. So that just take away from this. And what I actually wanted to show, so I'll try and, although I'm just to teach you, but I will try and show you what I mean by this particular one. So, I was telling you, so the other instances, I was just passing one particular file. If you see, I was just passing one particular file. But you can actually pass a lot of file into this particular command. So you can, if you like, you can pass file 2, you can pass this one, and you can pass a lot of file. You can pass a lot of file at the same time, and then it's going to compress all of them. So what is going to happen is going to loop over this list, this array of, I mean, files that you pass into it. So it's first going to like compress this, and then compress this one last. So you can actually pass multiple, and then if you show ls, you can see by 1, by 2, and those running tx.g set has been what has been compressed. So this is actually like a very good stuff, because at the end of the day, so instead of probably now doing everything one after the other, so you can just use. So this way I wanted to show you this is just to show you how you can actually exploit, wildcards that the Shadowland Kenny taught. You know, this is one way to actually do this. You know, I could have just probably done this instead. I could have just done this instead. That anything that end with .cst. I'm not sure whether you guys can still remember. So if I should do that, then any file that ends with .txt is going to be compressed. So it's going to compress this, it's going to compress this, it's also going to compress this. So if I show ls minus lh, you can see it's going to do that. So instead of probably typing all of this one explicitly, you can just, I mean, take advantage of wildcards. So you can also like all of those things that we are actually teaching you. So it's not as probably we're just teaching you in isolation. They actually have their own use case. So there are times when they will come in handy. So there are times when they will come in handy rather. So when they come in handy, so please always do well to remember and then exploit them, because they will make your life very easy, especially all these wildcards. So there are things that you will use a lot. So if you don't know them, and probably if you're still struggling or you've forgotten, like me, I've forgotten. So in fact, I've actually like probably refusing. There are a lot of things that, I mean, we've taught you that I can't even remember again. So, but white card, I can actually assure you, there is hardly any time you open your terminal that you won't be using them. So if you know that you've forgotten them, go and rewatch the video, study them again. And all this grep as well. Grep, I mean, those are the things that you cannot escape. All those pattern matching, all those grep patterns, and all these white cards. So please just go on. There's actually sweet stuff. So always have in handy. Yes. Okay. Now that we've compressed all our text file. So let's say probably I want to decompress it again. So I want to okay, let me ls. This one. Okay, sorry. So we have our file. So there's something I wanted to do. Oh, I can't remember. So let's just continue. Okay, so I want to demonstrate how you can actually use minus k. So this minus k, I was telling you initially that initially what we were saying is this, that okay, well, let's probably pass phi1.cst. If you pass that,
Hello, Abib,
so
are you sharing your screen?
okay, you cannot see my screen again.
No.
Oh, I'm so sorry. I don't know what happened. So let me try to share.
I don't know if that's what Esther wanted to raise. Or do you have a question?
So please, can you see my screen now?
Yes.
Okay. So I was going to show you how probably minus k option works. I told you that the default behavior of gzip, bzip, or bzip2 or xz is that when you use them without the minus k option, their default behavior is that they compress and then delete the original file and pass into them. I've demonstrated that. But let's say probably you don't actually, you actually want to keep the original file. So let's see what will happen. Let's say if I should use the minus k option, what I'm anticipating is that this particular file is going to be compressed, right? And then the original file is still going to be there. So I'm expecting that I will see two files that start with phi1.cst. So one with phi1.cst and one with phi1.cst.gz. So phi1, no such file or directory. There's minus LH. Okay, so let me just use phi2. So the reason why it's saying is because I've already compressed this, I've not uncompressed. So if I actually want to do that, so I first need to do this and then now run this. So ls minus lh and see the original file was kept. You can see, and then this one has been compressed. So I actually cannot probably, so most of the time I know we don't usually use this minus k because it doesn't make sense. Because by the time you actually decompress, you can still get the original file. And then by doing this, you're actually taking up space on your computer. Although these are bytes, you'll be saying, well, they are just bytes, sure. Maybe their size is not that big. But by the time you start bioinformatics proper, you will see the size of the genomes might actually be like megabases. An average bacterial genomes have like probably between 3 to 5. The genomes we'll be working with is going to be between probably 3 megabytes, between 2 megabytes to probably 3 megabytes, or 11 or 20. In case we're working with big, like Fabio assassinated vector stuff. Yeah. So, and then, so I mean, this was for gzip. If it is bzip that you're actually probably interested in using, so all you just have to do is still the same thing. It's still the same thing. It's still the same thing. What you just have to do is change this. It's only this thing that is changing. Bzip. We will use bzip2 and then ls minus lh. You can see we have one that has with bzip2. Can you see? It's just the same thing. So, and whatever you can do with gzip2, you can also do it. If you do the minus k option, the phi1. So I don't have any phi1 again. So I first have to like probably decompress either phi1 dot pz2 ls. So, and then whatever you can do with gzip, you can also do with this. So you can probably compress and then keep the original file as well with this. So that's actually what we are seeing. So what happens here is that I compress using file1.txt. I'll also keep the original file, and we have the original file, and we also have what we've compressed using bzip2. So I mean, they are just the same. So all you just have to do is keep changing. Let's probably are interested in gzip, use gzip. If it is bzip, use bzip. It is xz2, use xz. So, and then the last thing we'll be talking about is going to be decompression. Although I've been using some decompression stuff, like this thing that you are seeing that I did there. So it's a way to say, okay, decompress. So, and so there are so many ways that you can actually decompress your file. So many, I mean, just 2 ways rather, as I know of. So the number one is use gunzip. So this one is another command on its own. So, you know, when we were compressing, we were using gzip. If you want to unzip a gzip file, you use gunzip. So this one is another command on its own. And if you want to decompress a bzip2 compressed file, you use bunzip2. And if you want to decompress an xz compressed file, you use onxz, and then the name of your file that ends with either of these extension, probably .-gz or .bz2. So let's try and see. So let's see what we have here. So we have like a bz2 compressed file. We also have gz compressed too. So let's try and decompress using the first method. So the first method is, okay, I want to decompress this, right? So what will I do? I'll put gunzip, and bear in mind, you should have this at the back of your mind that whatever, so if you compress a file using gzip, you can only decompress it using like gzip algorithm again, whether gzip or using gunzip or gzip -t. So you cannot say, okay, you want to now like decompress a bzip2 file and a bz2 compressed file using another tools that is not compatible with it. So it's not going to work. So for example, so let's try and unzip. Let's try and decompress this particular file that we've compressed using gset, and the syntax is gunzip, then you type the path to that particular gzip compressed file. And by the time you do this, you say file 1 already exists. Do you wish to overwrite yes or no? You can put ls-lh, and then we can see we no longer have it. We no longer have a file that ends with .gz. So that means we no longer have a file that is compressed by gz and gzip rather. So you can see. And if you want to decompress a bzip2 file again, so this is what you do. Remember this syntax, bunzip. Let me try and clear my terminal. bunzip, ls-lh, bunzip, unzip2, and then the path to the file that you want to decompress using bunzip2. And then by the time you do that, you have ls-lh. Okay, saying bunzip output file already exists. So this one is now actually prompting me for, so the reason is because I already have a file. So probably let me just probably remove this particular file. If I remove this, then I can now rerun. Let me now rerun this. And then if I could do that, I should have my file. You can see I no longer have file 1, like a bzip2 compressed file. So that's actually one way to decompress a file using bunzip or gunzip. So the second way is you are still trying to like retain, we still retain this particular command gzip, but the only thing that you are adding is but adding minus D option. So I'll show you what I'm talking about. So let me try and gzip a file. Gzip this, then ls minus lh. I have that file. Okay. So let's say I want to now decompress. All I just have to do is add this minus D option. So I don't know the one that probably you actually prefer, whether writing G on C or using this minus option. So whichever flavors that you like is for you to decide. So, and if I do this, you can see. So it has been what? It has been decompressed. Yeah. So this is actually the end of today's class. But before you go, so there was one particular stuff. So before we move on, but please, do you understand today's class at all? Do you understand? Okay, thank you very much. All right. So, but before we start leaving, so there's something I want to tell you regarding how this compression actually works behind the hood. So, you know, majority of the files that we'll be working with, there will be unique file. Probably they just have like A, T, C, 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 A, T, G, T, A, T, 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 A. So there will be something like this. Let's probably have a faster, or probably it is DNA sequence or FASTQ file that you're working with. Can somebody tell me the number of characters that we have here? Please, let's not waste time so that we can leave very early. Can somebody tell me the number of characters that we have? Yeah. From yes to hear me. Can somebody tell me the number of characters? Eh? 23. Yeah, 23.
Yeah.
So we have 23 characters. So can you tell me the number of bytes that we have? 23 characters. One, two, three, four,
That should be
five,
around
six,
2.5
7, 8,
bytes.
10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So we actually have 24. If you remember, I said in our last class that we can have, like, there is an invisible character that we don't usually see, but it's always, I mean, at the end of your line. So if we should actually put this thing, so we can actually test it out. Although it is 23, but it should be 24. And we will see that. Let me try and create a file. So nano example .txt Control X gets Y ls minus lh. This example, you can see it is 24. And the reason why is because this particular one, although you are not saying it by the time you you type something on your, in your text editor, you are not saying it. But at the end of every line, so there's always an extra character at the end of your line. So, and this particular so this counts as 1. And then you add it to the 23 that you already have. So that's why you have like 24. So this 24 characters means that we have what? 24 bytes, right? It's also 24 bytes. Because bytes and characters in the way they are kind of like talking about the same thing. And so by the time you compress, and this is how compression works, by the time you compress, most of this compression, what they are just looking for is they're looking for repetitive sequence. So what will happen is, okay, A is not being repeated. So you have A in the first, sorry. So you have A in the first system. After, this is compression. So compression. So A will be here. So C will also be here. And followed by A. And then look at this. How many C do we have? 1, 2, 3, 4, 5, 6. So instead of writing all of this, what will just happen is 6C is what will be coded. And then you have what? A again. You have your T again. You have your G again. You have your T again. You have your A again. And how many T do we have? 1, 2, 3, 4, 5, 6, 7, 8. Then 8 T. 8T. Right. And then you have your A, then followed by this end of line. So can somebody tell me the number of characters that we now have? How many characters do we have after this? So we just have to like count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 characters. And then after that, what do we have? 14 characters. We have counted this line, and then which is equivalent to what? 14 bytes. So what majority of this, what they are just looking for is repetitive stuff. And you can see by the time you compress, what you will get is you are getting the reduction in your words, in the number of bytes that you have. And that's because you are using, by doing this, you are using less characters instead of spelling. So by the time you now want to decompress, so the algorithm already knows that, okay, this one is A, this one is C, this one is. So by the time it sees any number or things like that, you just okay, C. So it has like an efficient way of representing things. So it can actually probably recognize what it has compressed and whenever it is decompressing it back. So I can just, by the time I see this, I can go, I should repeat C 6 times. Or it might be probably this the other way. I don't know how the way they do it, but show that you are by the time you are decompressed, you are just looking for repetitive stuff, and then you are trying to like use the short spots to just decrease it. Look at this. In this particular, in the original file, we have like 24 characters. But by the time we decompress, what we have is this. So I was going to like say this in our last class, but somehow it eluded me, so I couldn't say it. But this just to show you. So this is just one way, one good way of how this compression tools actually work. But they are even now much more smarter than the way I've actually demonstrated here. So, but basically what they are just trying to like do is to find, to try to see whether they can see a pattern that is repeated many times and then find the ways to probably now use fewer characters. I'm not sure whether you understand what I'm trying to talk about. So do you understand what is going on? I mean, do you have an idea how this compression tools actually work? Or does it just like a simplified version of what is going on? Not really. Okay. So yeah, I think with this, we've come to the end of the class. With this, come to the end of the class. And next, in our next class, although I think I should be the one taking it, but I doubt my availability on Friday and Saturday because I'm traveling on I'm traveling next week. But I don't know who will be taking it. I don't know how it's going to work. Probably to check out comments on that. I don't know the. And we've been missing classes these days. So it's not as if probably we actually wanted this report. We have like we've been busy recently. I won't like we've been busy. I know we are working as well. So, but I actually doubt my availability because on Saturday I will be. Oh, all right, we'll figure it out. Yes, I think I will send it. Tochukwu already. I'm not sure that Tochukwu has the slide, but let me see. Let me share it with him. So please, do you have any question? If you have any question, go ahead. Please, do you have any question? Okay, please go ahead, Alima.
Okay, yes. My question is that you said if the for the file to be compressed, like there'll be like if there's like several characters that occurs multiple times, then the it's going to like be compressed like 60 and 80, like the example you gave. So what if there are no
Yes.
multiple characters to be compressed like that? Does it mean that the file cannot be compressed?
So yeah. So can you hear me?
Yes, sir.
Okay. So if you don't have, so it's still going. So that's why I said. I mean, this compression tools. So this one is just like a crude example of what's actually going on behind the hood of some of these compression tools. It's just like a basic stuff of what's just going on, but they are now more, I mean, advanced. So they will still find a way to do their best to compress, but they always do better. They do better when they see all of this repetition. So if they are not, repeated, they don't see probably unique stuff, unique pattern that can be. I mean, they don't see any pattern that can be probably represented using this way. They will still try their best in probably compressing, but they don't really do very well relative to when we have, I mean, repetitions in the text files. I'm not sure whether you understand. They'll still try their best, but they don't always do very well. Relative, like I'm trying to like compare two things. Now let's probably have like a file that contains some of this repetition here. And now have another file that does not probably contain some of this repetition. So by the time you actually subject them to compression, the one with repetition is actually going to be, despite the fact that let's probably I have another one that is something like this, and I have another file that is this, and we can even test it out on the terminal as well. So let's just say probably we have see the same length of characters: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, and V. So we know there is no any stuff there. I'm not sure whether they are the same lengths. They're the same lengths. So in this instance, let's even try. Let's try this on the terminal. So Control LS. So I'll just modify. So remember, let's even look at the script generate. Okay. So what I will do is this. So I will do bash generate. So in the last class, I wrote a script just to repeat something multiple times. So what will happen is that okay, let me see the syntax here. Control at generates. Okay. So let me now bash generate. So for this echo this. Okay, so my $1 has to be the sequence I'm passing, and my $2 has to be the name of the file. So I will just copy this from here, and then I will name it file1.txt. So if I now less file1.txt, you can see it did work. Oh, sorry. AAATTT. Okay, didn't work. What I'm trying to do is this. Oh, good. At generates ls for I in, so bash generates $1 v then file1. Let me try and delete. Okay, so I have the sequence. So I have that sequence. A, T, C, 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 C. All right. So let me do that one also for phi 2. So remove phi 2.tst. Remove phi 2. What's wrong with me? Phi 2.tst. Then bash generates this. Then I'm going to copy this up to this point and then name it phi 2.tst. So less phi 2.tst. You can say I have that. But if I should show you, like the two of them, we have the same size. Phi 1, phi 2. You can see. We don't have this, so almost similar. They are the same lengths. A, B, C, D, F, G, H, I, J, K. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay. So I'm going to delete it. I want them to be the same time, the same size. Remove phi 2. Then 22, 22, x. So ls minus lh. So you can see both phi 1. So both phi 1 and phi 2, they are the same. They are now the same length, right? I mean, they are the same size. 4.7 kilobytes, 4.7 kilobytes. So let's try and compress the two and see which one will, using the same two. So which one will actually work perfectly. So I will use gzip, then phi 1. You know, I told you you can pass multiple stuff to at the same time. Phi 2. So ls minus lh. Ls minus lh. You can see for phi 1, look at the compression, 72. So it still managed to compress phi 2. That's why the phi doesn't have repetition, but you can see that compares to this one with repetition. I mean, it does better on the phi with repetition compared to the one without repetition. But it was still able to like achieve the compression. I'm not sure whether that answers your question, Adima.
Yes, thank you.
Yes. So it will still find a way around it, but they don't always do better compared to other files with a repetition. So that's just take away with I mean take away from this class. Yeah. Is there any other question before call it? Okay. Any other question?
No, after my own question.
I didn't see your question. Please take me along. Okay, Mr. I'm not going far now. I'm still within Nigeria. So I just want to go to the yeah. All right, Tochukwu, I'm not sure whether you can comment on the class next week, but I'm not sure that you might be available to take it since you will be back before. Tochi.
Yeah, I'm with you, Habib.
Okay. Or should we discuss it later?
I think we should discuss later, please. Yeah.
We'll discuss it later. All right. Let me see the curriculum.